Stat A.
Actually, your whole class is going to be gone tomorrow.
8 R. Okay. Unit 8 review. So basically, what is it that we need to make sure that we know? There will be no index card, and on this one, it's going to be going on 2 real full lessons and concepts for which this examination. The major thing here is that, and this is going to be the main thing you're going to have to learn how to do. If you haven't, is Unit 7 is basically on this exam, right? Because in order to answer the secondary questions, in order to check those conditions with proportions, most of that stuff was on the previous exam. So I would say about half the exam requires you to do what you did on Unit 7. Normal model, using normal CDF. So, but again, you've been doing it in your assignments. There's nothing in regards to like, hey, you haven't been practicing it. It's been 6 days of work and practice and learning about sampling distributions of sample proportions and means. So we're talking here about the sampling distribution of a sample statistic. And notice that I'm saying sample statistic in this case, not the sample mean or sample proportion, because basically what we're going in is we have 2 major ideas that we need to know how to do. One, where the statistic is p hat, the sample proportion, and the other one where the statistic is x bar, the sample mean. So overall, I mean, most of it is very, very much the same. We're sampling from a population, and we need to understand that there are, first off, certain assumptions and conditions that we want to check. We have some assumptions. We're going to do them side by side so that you can see how similar they are. And the assumptions and conditions are S-I-N, which is the same thing over here, S-I and N. The first one, of course, is that the sample is random. So we want to have a sample that is random. We want, and of course, it's exactly the same over here. The sample, actually, you know what? I'm going to change these, the S and the I. I'm going to change the color here, just back to black. And the same thing with these ones, back to black. And so once again, also that the sample is random. We have here the 10% condition. We have, once again, the 10% condition. And the 10% condition is that the sample, basically, the sample is no more than 10% of the population. So once again, the same thing here, that the sample is no more than 10% of the population. Now, basically, this happens right here when we are sampling without replacement. So I do want to note that this condition is without replacement. Without replacement. And actually, I'm going to put that. I'll put that on a different line, actually, down below. I'll update that right below, actually. So basically what that 10% condition is that if we are sampling without replacement, which means that we cannot select the same individual more than once, and again, it's both the same on the same side right now. Because of the fact that if you sample more than 10% of the population without replacement, which means that you cannot select the same person twice, then the independence between the probabilities, that the fact that we know they're not going to be the same probability, because every time you select someone, there's one person less. If you're not selecting without replacement, all right, if you're selecting with replacement, every single time you select one, you throw it back in, and you select it again, and you throw it back in, and you select it again, or the probability just never changes because there's an infinite amount, then the 10% condition is irrelevant. I do want to note that, okay? So, for example, if we were sampling like M&Ms from a factory, well, the factory is going to keep producing an infinite amount of M&Ms. Every time there's an M&M, there's more M&Ms that are coming in. So even though we're sampling, we're going to take these 30 M&Ms. Even though we're taking these 30 M&Ms or 100 M&Ms, we have to understand, well, there's an infinite of M&Ms. So it's not changing the probability. We don't have a finite population, which I'll get to. And then we get to N. This is the normality check, and this is where it becomes different. We have two different normality checks. We have a normality check here, and we have a normality check here. Okay? And this is where things are different. The normality check for proportions is called what? This was what's on the last exam. How do you check for normality with proportions, things that are successes and failures? What is it called? It was on the last exam. This is the success and failures condition. So the normality check is called the success and failures condition. The success and failures condition. And that is that N times P has to be less than or equal to 10, and N times 1 minus P also has to be less than or equal, or sorry, backwards, terrible. At least 10. So we need at least 10 successes, and we need at least 10 failures. That is the success and failures condition, which is the normality check for sample proportions, for the sampling distribution of sample proportions. For the other one, and I'm going to simplify it down to two different ones. For normality check in the other one, there's two different ways. Well, this is the nearly normal condition. The nearly normal condition. They are different. There are two different ways that you can do this. One is that the population is approximately, or it is, I'm going to put it in a box right here, is normal or approximately normal. So if the population is normal, then the sampling distribution it already is satisfied, basically. We just have to state, hey, it's going to be fine, because since we're sampling from a population that is basically normal, our sampling distribution will be approximately normal. Or N is greater than or equal to 30. Okay? This is an or. One or the other has to be true. If these are true, if all of the conditions pass, then the distribution is approximately normal. It is approximately normal. We can approximate the results with a normal model. But over here, the mean of the sampling distribution of sample proportions is just equal to P, the true proportion. Whereas the standard deviation of the sampling distribution of of sample proportion is the square root of P, 1 minus P, over N. All of that is underneath the square root. This is the calculation you've been doing. Whereas on sample means, the mean of the sampling distribution is simply the mean, which is going to be given to you. And the standard deviation is the population standard deviation that is given to you over the square root of N. The goal is to use this. And here's the thing. If you don't know how to calculate the mean and the standard, if you don't know what the mean and standard deviation are, okay, you, on the exam, you mess up the condition checks. You know, you mess something up here and all that. All right. You'll lose some points there. But then everything else is fine. As long as you know how to find the mean and standard deviation of that proportion, of that sample distribution. So if you don't know, especially with standard deviations, then what's going to happen is that every problem, the problems that you're going to follow up, you're going to get completely wrong. Now, I'll give you some partial credit, of course, and I'm going to hand back the previous exam so you can see what happened with those ones. But if these are wrong, then the normal model problems that follow are all wrong. Same thing with the means and standard deviation. If we're talking about means and you give me answers and talking about proportions, that doesn't make any sense. You're going to be losing some major points there. Now, with sample proportions, typically what's going to happen is you're going to get some question about, you're going to be given, you want to find like the probability that X is greater than or equal to some value. All right? What you have to do is understand that this is the same thing as saying that the probability that P is greater than or equal to whatever that X value was divided by N. And if you're wondering, wait, what is he talking about right there? Well, when you make your normal model sketch for the question, here is your mean of P hat, and then the cutoff value, whatever it is, for example, let's say it's right here. This is your, this is your P, which is X1 over N. And then you would attack the problem like that. So if it says, what is the probability that at least 15 of the 30? What's the probability that at least 15 of the 30? Well, you're not using the value of 15. You're using 15 over 30, which is 0.5. So 0.5 is your cutoff. And then you would do, in this case, a normal CDF, X1 over N, comma, 9999, comma, P, comma, square root of P, 1 minus P over N. Now, these values that you find over here are what you've already calculated as the mean and standard deviation. Remember, that's the mean, that's the standard deviation. Whereas, if we're talking about sample means, this question is, I think, almost a little bit more straightforward. You're going to be finding the probability that, this should be a P hat right there. Sorry, I'm just recognizing that. P hat. You're trying to find the probability. They might say, to give you the probability that the sum of X is greater than some number. I'll call it K. Well, actually, let me change it right here. We'll say that this is a less than or equal to. All right, these are the tricky problems that I'm trying to give you. You have to understand that this is the same thing as finding the probability that the mean is less than or equal to K over N. Because this right here is the sample mean. So these were in regards to yesterday's problem. So for example, the elevator problem. You had 10 people in the elevator. The elevator's weight cannot exceed 2,000 pounds. So if there's 10 people, then the average weight of each person is 200 pounds. That is the number you're using. You're using the 200 pounds for the sample mean, the average, not the 2,000. And then, you have your sketch, and here's the mean of X bar, and here's your X bar, and you're gonna do below, and then you have a normal CDF, negative 9999, comma, X bar, comma, the mean of the sampling distribution, comma, the standard deviation of the sampling distribution. I also put some multiple choice in here to understanding conceptually what is going on.